To the North Central U.S. Climate and Drought Outlook for January 21st, 2016. Welcome back if you've attended some of these before, and welcome to the presentation if you've never done that. So today we're going to have Mark Sobota from the National Drought Mitigation Center give us the briefing. After the briefing, we will we'll take some questions. And I'll try, if at all possible, to unmute you all, but I'm not sure if that'll be successful. So I understand that *6 or number sign 6 can get you on if need be. So you can always raise your hand, and I can attempt to unmute you as needed. So hopefully you all can hear me. And Mark, why don't you take it away, and I'll put myself on mute. Thank you.
All right, thank you, Doug. Good day, everybody. Kicking off this year's first climate and drought outlook, although primarily focused on climate. Not a lot of drought in the region, as we'll see here in a little bit as we step through the slides, so we'll just jump right into it. And we usually like to acknowledge our partners in this process. And Doug, it's not letting me advance my slides here. Not sure why.
Sorry about that, Mark. That's interesting. the usual issue.
Yeah, there's always hiccups.
Yeah, great.
You are seeing my title slide, though, right? You are seeing the title slide still.
Yeah, well, I do see that, but you changed it and it didn't change. Let me go back to me. All right. Now let me go back to you and see if we have any better luck.
Okay.
We'll try it one more time. If not, I'll have to run it off mine.
Okay, I'm going to show my screen here again. Okay, it looks like I was able to advance it there. Okay, like I was saying, we've got a lot of people obviously behind the scenes that help make this series go, which has been going now for a few years, and always has a good amount of information that comes from folks on the ground, like many of you on the call, and just listening to a few here that help sort of herd the cats every month, you know, especially Doug and the folks in his shop there in Central Region, both NOAA and Weather Service, Dennis Toddy with South Dakota, and then we also have most of the state climate offices are very involved, as are the regional climate centers and other agencies as well, like the Corps of Engineers, USGS, and folks like us and the regional climate centers. So you can find access to all of those if you have an interest in past climate events. And these briefings, you can find them at the URL here listed on this page, as well as the recorded presentations. And as Doug mentioned, at the end of this, we'll take some questions. We should have plenty of time as I step through this. So here's an outline of what I'll cover over the next 35, 40 minutes max. Sort of a climate recap of how we ended 2015, quick snapshot of 2015 itself, where we are now as we head into the new year, and then what are the forecasts and outlooks sort of showing the way here for the next few months in the region. So just a brief recap, a pretty quiet year, relatively speaking. There were still 10 of these quote-unquote billion-dollar disasters around the U.S., not so many in this region per se. There were some severe weather outbreaks, but you know, like I said, from a drought standpoint, that's been more dominant on the West Coast. And so this year was a little quieter with regards to that. So how did we end 2015? Well, it's pretty obvious here that December ranked as the warmest on record for virtually every state east of the Mississippi, and east of the Missouri for that matter as well. As you can see here, all the red states, and if it wasn't the warmest, it was right up there in the top 5, top 4 for those states, except for South Dakota there in the Missouri Basin, as well as the Ohio. If you look at precipitation in the lower right, not only was it the warmest on record, but also the wettest on record for Iowa and Wisconsin. And, you know, obviously this is a little unique. I think Doug and I were chatting, going through materials for this briefing the last day or so. Not a pattern you would typically see in the summer months when you would have really hot weather you would expect to see more of the dryness and drought side of things. Not that you couldn't have some rains in there, but just pattern-wise, this has worked out that we're seeing a lot of red and green on these maps in this particular region during the winter. And what that meant is we saw a lot of that come in the form of rain and not as much in the form of snow. We've had slow ice up on the lakes, including the Great Lakes, which I'll show in a little bit. As a result of those warmer temperatures and a lot more rain, which has also led to a very saturated soil profile. Capturing the last 3 months of the last quarter of 2015, pretty much the same pattern. Certainly in the top 2 or 3 for the hottest quarter on record when you look at October through December, all those states in dark red. And then we have a few of the states, including Missouri, which was their wettest October through December on record. And again, those go back through data through 1895 provided by, that URL needs to be updated. That's the National Centers for Environmental Information, which is the new home and branding for what used to be the National Climatic Data Center. So 2015 as a whole, here you start to see some of the aspects of that western drought I was talking about up front. The 3 red states up there, Montana, Oregon, and Washington, hottest year on record, but also down there in Florida. And many of these states are, if they're not, they're top 10-ish in the western part of this region, from Wisconsin over to Montana, including the Dakotas, Nebraska, Minnesota, definitely up there in the top 10, even if it's not the hottest. And if you look at rainfall over the last year compared to the history going back to 1895, pretty wet in the Midwest, a little drier as you get out into the headwater areas of the Missouri River Basin, say in Montana, Wyoming. Southern Plains, we broke that drought down there. You see the wettest year on record for both Oklahoma and Texas, quite a change of events with big rain events in the spring in the May-June period, and then a pretty long period of drought again, and then some really big rains again in the fall. So they've essentially broken that drought down in the Southern Plains. Zooming in on this region, if we just look at what December brought, I was talking about those warm temperatures and some pretty heavy precipitation in some of those regions instead of snow as a result. You can see departures anywhere from 6 to 10 degrees, 12 degrees above normal or more, especially in the Great Lakes and Midwest. Still a warm signature there as you get out towards the Missouri Basin before it cools off a little bit out in the Front Range area in the high plains. Precipitation, not only was it warm, but you're seeing lots of dark blues and purples there in the Great Lakes, Midwest, Northern Plains, and eastern Nebraska and Missouri, where we saw 150 to 200% or more of normal. These are big departures, as you would suspect. I mean, this is rainfall that we would have typically expected for many of these parts back in the spring and May that we were seeing in December with those cool temperatures. So it just sat there and worked its way in, and a lot of it did run off as well. So there's some concern about that as we head towards spring. Looking at the water year to date, so going back to October 1, when we talk about the water year, that's sort of the reset button for off-season recharge of the soil profile for both planting, for irrigation, sort of looking at that from a water supply perspective in the system. Temperatures have been well above normal, particularly as you head up towards the Canadian border and across Wisconsin, UP of Michigan, Minnesota, and North Dakota. Temperatures anywhere from 6 to 8 or more degrees above normal during that time frame. But region-wide, it's pretty warm everywhere. And the areas that aren't, parts of Wyoming and the headwaters of Missouri and Montana, are just barely below normal, so certainly not frigid, certainly not a deep freeze. So when I've heard people here recently talking about the real cold snap, this is relatively speaking not been very, very cold at all. And so looking forward, this is what we'll talk about what the forecasts are going to bring for the next few months later on. Precipitation-wise, for the same periods, going back to October 1st, again, that recharge period, which is always critical for pre-planting in the spring from agricultural interest, as well as for winter wheat farmers and livestock producers as well for forage. We can see, though, pretty good rains here, again, virtually region-wide. A little bit of a dry pocket, which I'll show later on the drought monitor, that we're seeing in parts of North Dakota, north central South Dakota, and eastern Montana, central Wyoming. Other than that, though, the rest of the region's sitting pretty well, anywhere from 125 to 200% of normal over this 3-month period. Now, granted, that doesn't account for a large percent of the annual precipitation total, but it certainly is good for recharging the soils, and too much could start to be an issue or a concern if this pattern continues. So that's kind of the climate recap. We'll move now towards current conditions before hitting the forecast. So this is a quick overview, just looking at snow extent and the amount of water in the snow, more specifically, or snow water equivalent as we call it. You can see, and most of this over the central region, not a lot of large amounts of snow cover or very deep, so not a ton of water there, which might be good given a lot of the rains we had earlier that have worked their way downstream but have certainly saturated the soil. So that's not necessarily a real bad thing, that we're not talking about real heavy snows and then worried about rapid melt or rain on top of snow come spring. But any sort of warm-up and continued rains will obviously cause some concern if that pattern continues. And so here you can see the situation where we have seen a rebound. You're probably hearing a lot about the drought in the West and California in particular over the last year or so. And you can see they have had a pretty good start to the snow season out there, and snow water equivalents have improved, but they are looking at a 3 to 4 year drought, so they have a ways to go yet. Shifting our attention over to the Great Lakes region and comparing this year, when we talked about those cold temperatures or the lack thereof this year, certainly if you go back to last year and the year before, and there were all these great pictures on the nightly news about the ice extent on the Great Lakes and how they were frozen over. So currently we're sitting here from the Great Lakes Environmental Research Lab. They're showing about 12%, just a little over that, of total ice cover on the Great Lakes compared to last year. I believe it was 24 or 25%, and the year before that it was about a third of the Great Lakes total ice cover at the same time of year. So we're certainly well below where they were, half of the extent of last year, though, indicative of the warmer temperatures that we've seen over the winter thus far. So it's probably no coincidence either that with that colder and snowier winters we've had the last couple of years, we've seen an uptick on most of the Great Lakes water elevations, going back now to probably the 13 and 14 winters, 2013, 2014, and now into 15, have helped spike all of these up above the red line, which is that average based on 1918 to present. We've jumped over all those red lines for all the major lakes out there in the Great Lakes. So improvement there as well. Now we'll zip back to the west and look at sort of a basin look at that amount of water in the snow. Snow water equivalent, based on data from the Natural Resources Conservation Service, has an upper elevation network called SNOTEL, snow telemetry, that they operate and have operated many of these stations now. We're getting 30 years of data, 20 to 30 or more years of data, so we're starting to develop a pretty nice history out there. This year we can see, as I mentioned earlier, some of those pockets of dryness, particularly in that Bighorn region and central region, north central region of Wyoming. That dryness has been starting to leak a little bit more westward towards Yellowstone and southwest towards Utah. And we've had that lingering dryness, a pretty severe drought that's been somewhat dampened a little bit this winter, but a long ways to go too in northwestern Montana. That does lead to some of these other maps I'll show you here as far as projected stream flow in just a little bit. There's that area that I was talking about in Wyoming that I'm circling here with the mouse in the Bighorn region, where all of these are, most of these are well below normal for snowpack for this time of year. This product happens to be updated monthly, and then they issue streamflow forecasts off of that as well. But when we look at the rest of the Missouri Basin in generally speaking, in Colorado, and then here in the Yellowstone region and up into the headwaters of the Missouri, not too bad a shape, but has been drained out as of late. So maybe that's more typical of what we might have expected to happen sooner in Montana as far as the El Nino pattern, where we did expect sort of drier conditions. They've had a pretty good shot in the arm thus far, which is great because it wasn't totally expected going into the fall and winter. Looking looking at a little broader picture, but looking now at stream flow forecast for that. Again, this is a real early forecast. It changes a lot. We're nowhere near the peak accumulation season. We're basically just crossing the halfway mark, depending on where you are. But we still see a lot of those oranges and red dots here, again, in Wyoming and parts of Montana that will feed. But we also have a lot of green dots as well. So a little hit or miss and a little greener as you get down into the Platte basins here. The North and South Platte basins not sitting as bad until we go up into the headwaters of the Missouri, which is more of a mixed bag. So this is, again, a very early cursory look at the forecast, and those obviously are going to get more refined and more accurate as we move into February and March and April. So stream flow, obviously a lot of black and red, a lot of black and blue on this map. And in the Ohio, in the Midwest, and even in the Missouri Basin, all in all, warm enough that a lot of these streams are still running, even some of the tribs. But the main stems certainly are in pretty good shape, and we've already had some minor flooding in parts. And with those saturated soils I talked about earlier, given the rains of December, the warmer temperatures, without a hard freeze on that, you know, that's of some concern. We did get a little bit colder snap here the last couple of weeks, which has helped for some areas, particularly feedlots and things like that, where they prefer not to be too mushy this time of year. So we are seeing some benefit of that, and some of that snow cover again does help insulate things like winter wheat and other. It serves as a protective layer for that. So snow is still needed for other reasons than just water supply. But we can see again a pretty good picture here as we zoom into the Missouri Basin. Again, outside of some of these basins there in north central Kansas, all in all pretty good for those that we've got recordings on. A lot of black dots, which are record high. And again, this is a 28-day average, so it's not as prone to the spikes of individual storms, but rather averages out roughly a 4-week period, and we're comparing that to that historical 4-week flow for that date moving forward, and this data comes from USGS Water Watch. Looking at the upper Mississippi, again, good, lots of black and blue dots on here, so we're really above normal on stream flow. Again, some of these gauges, when it gets really cold, you do have to take that with a grain of salt. It's not like what we're seeing in summer flow when we don't have any issues of freezing and freeze over on the smaller tributaries. But all in all, we know this picture is pretty accurate because it has been so warm and it's been pretty wet. And then shifting over to the Ohio, we can see here, again, same story, maybe not quite as wet, but still above normal. Nothing too concerning here from a drought perspective. We know that the stream flows are above normal. There has not been a lot of icing, as I mentioned, the slow ice up on the Great Lakes, and there hasn't been a lot of snow either. So that's been the story pretty much for this region, and this is a very large region, so that's pretty unusual. You know, so there's obviously some questions as to what's driving that on the INSO side of it, and earlier on in the fall, especially in the Northwest, what was driving it with regards to what influence did that warm water off of the northwestern U.S. Gulf of Alaska region, or the blob as they called it, what sort of role did that play in the pattern we've seen set up thus far? But we'll have to see how that plays out. Okay, some information here. Above Fort Peck, we can see we're tracking below the average, the 81 to 2010 average data here from the Corps. And then from Fort Peck to Garrison, same thing. Seems to be mirroring that year of 2001, excuse me. And you can see here that really record year of 2011 in black, and 97 here. So here's our average in red on these, and we're running below the average at this time of year for both this above Fort Peck and between Peck and Garrison. So as I will mention later, or maybe Kevin can allude to it a little bit more in the question and answer session, they've been more concerned about getting water out of the system so that they can have full storage for a flood control come spring. Now, soil moisture-wise, again, I talked about a lot of saturated soil profiles. This is looking at the total column, so the upper column, root zone, and the deep soil column. It's combining all of that. We're not just looking at the top a couple feet here. We're looking a little deeper. Again, all in all, pretty good. Again, these models sometimes you have to take with a grain of salt in the winter too, based on what's forced them and how the soils are behaving when they start to get a lot colder and we start to see frozen soils. But this year, given the fact that it stayed so warm and we haven't seen a hard freezing of the soil profile very deep anyway, it may be a little more accurate than a typical winter, but you still have to just kind of look at it as a convergence of evidence with a lot of other pieces to know how much you're going to trust this verbatim. But just in general, you can see the wetness in parts of the Midwest, Illinois, Iowa in particular, Missouri, eastern Nebraska, and Wisconsin, coupled with these other little bit drier pockets more in the Ohio headwater region, the Red Surrey, and over into the Bighorn region and eastern Montana. So all in all, the general pattern seems to match up fairly well, but obviously not exactly with what you may see in your local area. So jumping forward to the drought monitor picture here, not too much in the way of drought. Even on the U.S. scale, we only have 16% of the country in drought. So that's anything D1 or worse. Compared to just 3 months ago, we had roughly over a third of the country in drought is circled here. And a year ago, about 28%. So these numbers here, this current number is 16, just over 16% for the lower 48. We haven't seen that small of amount of drought in the U.S. You'd have to go back to about 2010, when I believe we got down to about 10 or 11%. So it's a pretty quiet period drought-wise since we've been doing the drought monitor, which now goes back to 99, 2000. So in the last 15 years or so, this would probably be one of the two lowest ebb years in drought. Even though we have this really intense drought on the West Coast, that's the only place it really is. And basically everything east of the Mississippi, there's just a few pockets of dryness. One of those pockets, though, is up there in the headwater region of the Missouri, or some of it is on that side of the divide anyway, and including the Montana and southeastern Montana and north central Wyoming area, which feeds the Missouri Basin. But really, a lot of just pockets of the yellow abnormal dryness. It wouldn't take a lot to knock those out as far as snow and or rain, but they are sort of lingering. And in fact, this lobe here in Wyoming, as I mentioned up front, has been expanding, while this lobe has been chipping away, and the drought has been eroding a little bit. It still has some drought here, but it has been getting better over the last few weeks to a month or so. So only 5% of this whole region, again, a pretty large region, typically, which you would associate with some winter storms, has been pretty much lacking. We had a lot of rain, obviously, so we've had good precip amount. It just hasn't been in the form of a lot of snow, and that means we don't have a lot of drought, which isn't a bad thing at all. In the Missouri, again, less than 10%, at just shy of 7% of the basin in drought for the Missouri watershed, catching some of that D2, but not much in Montana, mostly D1 on the side that's draining into the Missouri, along with the Bighorn region in Wyoming. Here's what we've seen since the start of the water year, again, roughly October 1st into September, if you will. We've really seen, again, couple key features here. The eradication of drought in the southern plains and lower Mississippi Delta, denoted by these darker colors of green and blue, which have been 3, 4, 5 class improvements just since September 29th. And then the Pacific Northwest, which has improved much more quickly than California because the regions up there we were seeing the blue and darkest green. They were not in the drought for 3 to 4 to 5 years like parts of California and Oregon. So that pattern needs to continue before we start to see those sorts of colors come into play in California. But in this region, mostly improvement, some light shades of green, nothing real major, except for that feature, again, of the expansion I mentioned earlier in Wyoming and Montana. We've had a 2-class degradation over the last 3 months or so. in drought in that region, and a little bit as well in the border region between North and South Dakota. But other than that, pretty quiet. A lot of white, a lot of no change, and given the pattern we've been in, not unexpected. This just zooms in and shows you that change map just for this region, so I won't belabor the point there, and we'll just move on. Okay, so let's jump into the forecast. So over the next 7 days, here's the what they call the quantitative precipitation forecast, or liquid equivalent. Again, this region, by and far, not a whole lot of activity. So we're going to see where this ridging brings in some warmer temperature in the 8 to 14 day, but you know, we're going to have some southerly flow and get some warmer temps. But you can see here the line that's marking the storm that's going to push off to the east, that's just staying south of this region right now and clipping parts of the Midwest or the lower Midwest as it moves eastward. But storm-wise, you know, not a lot of precip up there in the Rockies or what's going to be feeding the Missouri, at least in the next 7 days. But pretty heavy rains up on the coastal reaches of the Pacific Northwest and down into Northern California. And then in the mid-Atlantic and southeastern area, we've got quite a bit of rainfall expected, anywhere from 2 to 3 plus inches. Looks to be pretty widespread down there, so it could be a pretty wet 7-day period. Jumping forward for the next 2 weeks, which will take us, believe it or not, already into February, then we can start thinking about spring. Real warm signature here. You can see these dark shades of orange and red, much greater likelihood of being above normal over the 8 to 14 day period, which again takes us to February 3rd. And on the precip side, we see, again, a relatively wet pattern associated with that, or at least an enhanced probability of above normal precipitation, particularly in the Great Lakes region. But really region-wide, there's at least, it's in the shading of green, which tilts the odds just a little bit more in favor of being wetter than normal. Can't say as to how much above normal, but at least that's what we're seeing right now, along with some pretty green areas to continue that drought busting out there in the west. So we've heard a lot about El Nino and what has it been doing, and one of the stronger ones we've seen over the last few decades. Well, now it's probably likely reached its peak and is starting to wane off. You can see most of the models are in agreement as we head into spring that it will tail off, but the impacts, while we've reached the peak sort of from a physical state or from an oceanic temperature state, there's sort of momentum and inertia that happens that the impacts will follow that now, what we expect to see. So that's why we're still a little conservative on what's going to happen out west in particular, because, you know, typically we would have expected drier conditions even by now, say, into the Missouri headwater region of Montana, parts of Idaho in the northwest. You would expect a drier signature, and that hadn't really transpired up to this point. So that doesn't mean it can't turn off the tap right now and go dry for the next 3 months. If we start to see the true full brunt of the impact influence from El Nino, is going to come after the peak in the oceanic state. So now all these models are showing the fall off, and it's not untypical at all to see you go from an El Nino right into a La Nina the next year. So by next fall and into the winter, and I'll go to the next graphic, you start to see that blue bar start to amp up here as we get into the fall period. Almost a 40% probability of either being a La Nina, over 45% of being neutral, whereas our El Ninos really start to fall off. So it's not looking probable to see back-to-back El Nino events, but rather something more neutralish, or even perhaps reverting over to La Nina, which typically my drought radar starts to perk up. Not that for this summer, in particularly speaking, but maybe for next year. After a La Nina winter, I tend to start thinking drought. But drought can happen any of those years, whether it be neutral, cold, or warm event. So hot off the presses, they just released out of the Climate Prediction Center the monthly and seasonal outlooks. The top 2 maps on the top left is the temperature for just February, and on the top right is precipitation just for February. Really classic El Nino pattern right there. Warmth across the northern tier states, and the lobe of dryness there in the Pacific Northwest as well as the Great Lakes. When you look at the 3-month period, February through April, starting to get us more into that springtime, they're continuing to still show that basic pattern of warmth across the northern tier states of this region and dryness in the Great Lakes. So we'll see how that pans out as we transition off of strong El Nino into neutral and eventually perhaps into La Nina, and how this will impact what we see for setting up the summer pattern and the spring pattern remains to be seen, but it's looking like that warmth still would keep us in sort of a very mild winter pattern, if you will, more west to east air masses and not so much a dipping of the strong Canadian air masses down, but that doesn't mean you can't get some cold outbreaks in there. But all in all, this is what the pattern's looking like it's going to set up as. And then if we shift forward one period and start looking at March, April, May, again, showing pretty much the same pattern for the temperature in particular. For the precipitation, you see a little bit of the green out there in the front range of the Rockies into the Platte basin area, and you still see a greater likelihood of being below normal precipitation in the Midwest and the Great Lakes, with a stronger tendency up there a little bit in the upper Midwest and the Great Lakes region in particular. So given those seasonal forecasts, they just issued the seasonal drought outlook, which looks at the next 3-month period, through April 30th, and you can see development in that yellow lobe is denoted in Montana. They expect that dry pattern, even though we've had some chipping away of the drought, that again, if we start to see more of the typical impacts of the waning El Nino, that we will see dryness persist up there in the headwaters of the Missouri. It's also interesting where, as I showed you on this last map and the one before, the dry pockets in the Midwest and the Great Lakes doesn't necessarily translate to drought development, because you have to keep in mind we have the antecedent conditions, which have been really wet. We have a full soil profile for the most part, and that's a nice buffer as we head into spring. And in fact, you're going to want it to dry out so we don't have the flood issues, and we want it to dry out at that time so the folks can get in the fields. So all in all, that dryness sometimes, and so they're not really showing specifically drought to develop in that region, even though the seasonal forecasts show greater odds of being dry. So to summarize, most of the region has been very warm and very wet, as we saw early on, with record temperature for a lot of states, and not record wet, but certainly very wet for some of those states. The Great Lake annual average water levels are all above average for 2015, and that's likely to persist through 2016, given the pattern we've seen. The Corps of Engineers has really been focused on evacuating stored floodwaters so that they can have a full amount of flood control storage available come spring. And these very wet conditions and saturated soils in the lower basins of the Ohio, Missouri, and where these all converge, sort of in the upper, between the upper and lower Mississippi, is of some concern, given how wet it's been there and the flooding we've already seen. And also on this slide here, the mountain snowpack and the snow water equivalent in particular, still lagging in some of those areas. So all in all, again, given some of the other concerns in the lower basin from a flood perspective, and also given the lack of heavy snowpack right now, that might at least help alleviate one portion of the equation as far as what we saw a few years ago when we had a lot of snow and we had some warm up and we had heavy rains on top of that snow. That can cause a lot of problems. So we're not seeing that set up as of now anyway, which isn't all that bad. So again, drought isn't a major issue, and some of that dryness is actually welcome in some of these regions, but we do anticipate some of that development of drought, particularly in the Missouri, upper Missouri basin and the Montana region. And El Nino has reached, finally, it seems like it's reached its peak and it's going to start to wane off, and may even develop into a La Nina by next fall or winter, but it's certainly too early to make that call. But now is the time when we can start to expect maybe the full brunt of the impacts that may come on the heels of El Nino waning off. And finally, most of the region looks to remain warm through spring. We do have those two pockets I talked about from a tendency to perhaps be drier than normal in the Great Lakes and parts of Montana over the next 3 months. Okay, so with that, just another information slide I'll leave up here for you. Yeah, that has some information. Again, these are all recorded and stored for you to come into later. And here, just some acknowledgments to partners in crime. I'm putting this talk together today. Dennis in South Dakota, Doug, Kansas City, Mike Timlin with the Midwest Regional Climate Center, and Natalie with the High Plains, and then Barb Mays-Busted with Weather Service as well. Okay, so with that, we'll just go ahead and open it up to questions, and we'll try to answer those questions, and if I can't, we'll try to direct you to some other folks on the call we know are on that can perhaps help.
Okay, yeah, this is Doug again. Thank you very much, Mark, for the presentation. I think there are a couple questions. Benjamin Diamond, would you try just pushing *6 and see if that takes you off mute, just for experimental sake? Because I think you had a question. If not, I can attempt to do it manually. All right, that didn't work. Hello? Hello? Oh, there we go. Hello? Anybody? Try and speak now if you have a question. Yeah, I see that there are some issues with the questions right now. My goodness, that's sad. There was an audio code at the beginning. Hopefully you guys all typed that in. Let me see if I can get to the questions. Amanda Schooling from North Dakota asks, does this map illustrate the rivers are not running in North Dakota? And I think she's referring, Mark, to the USGS slides you had up, the Water Watch ones.
Oh, can you hear me now?
I hear you now. What'd you do?
So, well, I didn't do anything. I think it was saying that the sponsor muted me, so I thought maybe you're trying to shut me up. Yeah. Without knowing the particulars of the region, we have had this recent cold snap. You know, trusting the stream gauges and some of those, especially in the tributaries where the waters, we're going to have frozen over situations. Even as warm as it's been, that can still be an issue as far as the accuracy of those readings. But on the main stems, and there's probably others on this line, with River Forecast Center or with a Corps of Engineers that can answer that question even better than I can. If you're out there, please chime in, either Jim or Kevin or others, or Doug himself, if you know some others on the hydrology side that can answer that question better than I can.
Well, generally, yes. As you go north, as you say, tributaries and the smaller streams and rivers do tend to freeze up, and there are problems with gauges. So there's not a lot of trust in the gauges when you have ice on the river for various reasons. It doesn't mean necessarily that the river has stopped running. It does mean that that gauge isn't really that trustworthy unless it's on a major river.
Yeah. But we know the general, we know the general pattern's been very saturated in general, and so then it's just a matter of waiting for things to thaw out. And hopefully that doesn't happen too fast. And like I said, you don't want a combination of real heavy snowpack out on the plains accompanied by rain on top of it, or you can get into a flooding situation pretty quickly, given how wet the soils are too. So, it's been warm though, and that's definitely played a role so far, as the soils haven't frozen up as much.
Yeah. So the next question along the soil moisture line is, how is soil moisture anomaly modeled? And I don't know if I can actually go to that, explain that very well. But Mark, do you want to touch on that or not?
Well, I'm by no means an expert either on. I'm not a modeler, so I'll just say that right up front. I have worked with those folks. The model I was showing you is actually what they call an ensemble mean, which means they run a handful of models to get these soil moisture anomalies, and so you're sort of just like a stream flow ensemble forecast or a climate ensemble forecast where you have a lot of models. You run them, and then you kind of see, is there a big spread between these models and the story it's telling, or are they in pretty good agreement? So the shorter that spread is, the smaller that spread is, the more agreement there is in the model, the more confidence you have of the conditions at hand, whether it be wet or dry. So each model handles the physics of how water works through the soil profile differently. They can force them differently as well. As far as what they're going to put in for the weather parameters that drive the model. And so there are these differences between the models, and that's why sometimes when they look at those mean ensemble values, they're trying to sort of get rid of some of that noise.
Yeah, and also, as we've said, reiterate this again, that the soil moisture models generally aren't good for your backyard or even a county. They're more broad scope, and of course they do take into, I'll speak generally again about those models, is they do take precipitation into account in a major way, so they do look at that. But as you go down through the soil profile, depending on how deep you want to sort of understand how wet it is, it does take time for that water to infiltrate, and it does take time for the models to, if you will, adjust sometimes to lack of water as well as lots of water, lots of precipitation. The next question is from Chris Smith. Any predictions for the polar vortex and how it will look? It will look for the Lake Superior area. And if you want to answer that, you can, Mark, or I can give it my best shot.
No, you're out of my comfort zone at that point, unless you have yourself or Barb on Winter Storm, or somebody else that can come in from the Weather Service perspective.
Right. So I guess what I would say is, generally speaking, from an El Nino perspective, and considering Arctic air plunges, as we saw, let's say, the last 2 years, into that area specifically, the best way to say it is the chances for a lot more Arctic air plunging down through that area are less than normal, simply because of the El Nino signature going on. Now, it doesn't mean it won't happen. Well, we just had one across the plains and Midwest, and it got pretty cold. But it's not, number one, it's not sustained, and number two, it's not all that cold. You may say, gosh, it is pretty cold, but it's in perspective of what's happened in the past. Looking at this is the coldest time of year. This is about the coldest climatologically. This week is about the coldest week of the year normally across much of the northern hemisphere. So I guess the best answer for future polar vortexes is that the chances of them breaking into the U.S. or affecting the Lake Superior are less than normal, certainly because of the El Nino pattern. I don't know if anybody else has a comment along those lines.
Yeah, and I don't know who you've unmuted, if someone else can speak to that or not.
I don't know either anymore.
Well, we did talk about earlier, I did mention that the influence of, we've seen this more, what we call the zonal pattern, where we do see more of that west to east air instead of north to south. And so that's kind of what Doug's talking about there, and that's going to give you, in general, doesn't mean it can't have some cold snaps, but it's a much more moderate cold event than those persistent talk that we kept hearing about the previous winters about the polar vortex.
Yeah, and there are other influences other than El Nino, as we all know, something called the Arctic Oscillation and such. And when that goes negative, we tend to have more cold air outbreaks. And it was negative last week, and it's just moderated somewhat this week. It can overrule, if you will, the El Nino pattern for a while, but eventually the El Nino signature, or whatever you want to call it, comes back, and that is sort of what's the main story, if you will, for climate so far this winter.
And Doug and Mark, this is Barb, just to add another word or two, not to harp on polar vortex too much, but our friends who look at these things a little more closely on a sub-seasonal to seasonal basis do think that we're a little favored to continue to tilt toward maybe neutral to negative AO. For the next iteration of a polar vortex perturbing out of the Arctic area, they do think it's more likely to tip into Eurasia, meaning they would get the cold air so much more so than we would.
And I think, Barb, everybody would clap on the call if they heard that.
I'm clapping here.
So I have one other question, just this time from Justin Durner, our USDA friend out there, and I'm sure he's asking this question from an agricultural point of view, is and something we didn't put up, but we will probably start next month, is what's going to happen this summer in terms of temperature and precipitation, and in other words, what is the Climate Prediction Center calling for? And in brief looks that I've had in the past, I won't put Mark on the spot right now, generally speaking, Justin, the pattern of El Nino, where it's warm in the north and cool in the south, sort of wet across the south and parts of the plains, and dry basically to the north, if you will, over the Great Lakes and maybe northwest. That sort of pattern sort of goes away come April and May, and then we transition, if you will, into more of a, well, what they're predicting is more of a warmer pattern across the country in general. So they're calling for better chances of above normal temperatures for the most part during the summer. Now, it's a broad brush sort of comment, and if you really want to know a particular area, we'd have to dig into that a little bit more. But there are also, I'll say, for the summertime, it's really tough on the precipitation side at this point in the year to give a lot of credence to any kind of precipitation outlook. So for the most part, again, due to the complications of forecasting this far out precipitation in the summer months, I think they're pretty much saying equal chances for the most, but again, for the most part across the summer. Now, as we get into the fall and really into next winter, I think odds are slightly in the favor for now of switching to an El Nino, or I'm sorry, La Nina pattern, which pretty much flips what you see right now in terms of the outlooks, warm in the north, cold in the south, to the other way. Cooler north, chances for cooler north a little bit better, chances of warmer south a little bit better, and almost the opposite also in terms of precipitation. But that's far out there, and I wouldn't make too many plans based upon that. I guess I got another question here from Benjamin Diamond. What is the Madden-Julian oscillation pattern? Is this having an impact? And Benjamin, that's a billion-dollar question, maybe trillion, depending upon what industry you're in. But boy, I'll start on this. If Barb or Mark want to comment, feel free. The Madden-Julian oscillation does have impacts, big impacts, on the northern hemisphere, especially North America. It tends to come in waves, and I mean that literally and figuratively. It's not something we usually talk too much about on these calls because they are sort of out of our range of what we normally talk about. I have not been tracking them, and it's not something I can comment too much on at today, but they do have big impacts, and they generally are, if you want to sort of simplify it, big, if you will, disturbances in the atmosphere which cause the weather to shift greatly in North America. It can really change things in a hurry, cause big storms, etc. When we're impacted by one. And yes, they do sort of originate around the equator, and yes, they do sort of get pulled up out of the subtropics into the U.S. Anybody want to?
Well, I was just going to add, Doug. As far as the influence here, obviously in the West, when you start talking, okay, why did this El Nino or La Nina not behave the way they thought it might? Is because they're kind of looking at those things on a seasonal basis. And here we're kind of looking at intra-seasonal down at a 1 to 40 to 50, 60-day sort of cycle that can put a wrinkle in things. And that's what makes forecasting so tough. Even when you've got a strong El Nino. I mentioned the blob earlier, the warm pool that was dominant. And you might have heard of this ridiculously resilient ridge that parked out there for a long time, was definitely having an influence on the climate and the weather patterns that spun off of these. So these sort of oscillations and how they all interact, I mean, that's still an emerging science to understand the interplay. But the Man Julian is more of an intra-seasonal versus an inter-seasonal or interannual, like we think on the terms of ENSO, for example.
I would invite any other questions to type them in, and if you have any. Otherwise, I think we've pretty much called it a day. I'll thank again Mark for his great help and presentation this time. I'm not seeing any other questions, so I think I'll call it. We'll try to get this phone thing worked out so that you all can actually speak to us. We'd much rather have that than listen to me read your questions. So at this point, I'll bid you a fond adieu and talk to you again hopefully on February 18th. Thanks, everybody. Have a great day.